This small workshop employs forging techniques to ensure that durable compressor crankshafts can be used in Pakistan. Despite having relatively rudimentary equipment, the final crankshaft is of excellent quality. They use high-quality steel billets to create durable crankshafts as their raw material. First, the craftsmen use a high-precision automatic cutting machine to cut the billets into standard sizes. The next step is to heat the billets to form them into the shape of crankshafts. Although their heating equipment is rather basic, it takes only half an hour to heat the billets until they glow red. The billets reach several hundred degrees Celsius at this point, making them too hot to handle directly. Instead, the craftsmen use long shovels to move the billets to the forging air hammer. The craftsmen then quickly forge and shape the billets. High-temperature forging rapidly changes the billet's shape and alters the internal crystal structure, improving overall mechanical performance. They do not use specialized auxiliary tools throughout the forging and shaping process. Instead, they rely on simple equipment and the expertise of experienced craftsmen to form the crankshaft's rough shape. The crankshafts are left to cool naturally since further machining is required after the initial forging. To facilitate subsequent processing, the craftsmen use molds to mark the crankshafts, trim the excess material from both ends, and cut the marked sections in the middle. This approach not only enhances machining efficiency, but also reduces several processing steps. The roughly processed crankshafts are then quickly transported to the finishing workshop. The crankshaft is still a rough blank at this stage, making securing it for further machining challenging. To facilitate this, the craftsmen use calipers to measure the center position and punch a locating hole with a center punch. This prevents the drill bit from slipping during drilling. With the combined efforts of two craftsmen, the rough crankshaft is soon secured, and the craftsmen can proceed with detailed surface machining. First, they machine the end journals of the crankshaft, a relatively simple process that mainly requires precise dimension control. Experienced machinists can quickly complete this task. The machining of the central crank pin is more challenging. To avoid angular deviations, the craftsmen perform precise measurements and markings. Despite clear markings, careful observation of the cutting conditions and frequent checks with a steel ruler is necessary during machining with the eccentric lathe. Due to the old lathe, processing a single crankshaft takes 2.5 days. Once this step is complete, the craftsmen proceed with detailed finishing. To cut a keyway in the front journal, they first drill a locating hole with a drill press and then use a shaper for precise cutting. The craftsmen repeatedly compare the workpiece with a mold to avoid dimensional deviations during machining. After an hour of shaping, the keyway is finished. Next, they drill oil passages in the crankshaft, a relatively straightforward process. The compressor crankshaft is finally complete after a final round of detailed machining. What do you think of the crankshaft produced this way?